Hello guys and welcome back to Chemistry Rules. Today we have a new lesson, application of the mole and molar mass. So let's start. Okay guys, let's start. So what is molar mass? So the mass of a mole of a substance is called the molar mass of that substance. So basically, molar mass, the molar mass of, let's say, an atom is just the mass or weight of that atom in 1 mole. Okay? So, the molar mass of an element is found on the periodic table and it is the element's atomic weight in grams per mole, abbreviated as G over mole. So, as we can see here in the two pictures on the left side of the screen, so the molar mass of hydrogen is 1.008 grams per mole and the molar mass of carbon is 12.0107 grams per mole. So, we can use this molar masses of elements, atoms, or other compounds to compute or to balance chemical equations in the later part of the chemistry course. Okay, so let's proceed to the conversion of grams to moles using the thing that we learned earlier, the molar mass. Okay, so here's our problem. So how many moles of potassium, abbreviated as K, atoms are in 3.04 grams of pure potassium metal? So we know that we have 3.04 grams of pure potassium metal, and we also know that the molar mass of potassium is 39.10 grams per mole. It is rounded to 2 decimal places. So now, please analyze the problem and the solution will be shown later. So please pause the video if you want to solve it on your own, or if you do not, then do not, okay? Okay, so here's the solution. So we have the given 3.04 grams of potassium. Then we will multiply it to the conversion factor, which is the inverse molar mass of potassium. So you have to take note of what conversion factor you will use. Will it be the inverse molar mass, or it depends on the situation, okay? So now, so we have the 3.04 grams of potassium times the inverse molar mass, which is 1 mole of potassium over 39.10 grams of potassium, is equal to 0.0778 moles of potassium. So the grams of potassium cancel each other, and then you just have to divide 3.04 by 39.10, and then you have the answer. The unit is moles of potassium. Okay, hello ulit. So now let's proceed to the conversion of moles into grams. Okay, so the problem is, how many grams are 10.78 moles of calcium, abbreviated as Ca? Okay, so we know that 1 mole of calcium is equal to 40.08 grams per mole. We also know that our given is 10.78 moles of calcium. So we just have to multiply the given by the conversion factor. It depends on the situation, of course. So now, if you want to solve it on your own, please pause the video. If you do not, then do not pause the video, okay? Okay, so here's the solution. So first is the given 10.78 moles of calcium. Now we need to convert it into grams. So to convert it into grams, we need to get the molar mass of calcium, which is 40.08 grams of calcium per 1 mole of calcium. Okay, so now we use the molar mass of calcium, not the inverse, as the conversion factor. So the mole of calcium cancels itself out, and we're left with 10.78 times 40.8 grams of calcium. So if we multiply that, the answer is going to be 432.1 grams of calcium. Okay, so it's just that. The next is converting grams to atoms. So we have converted grams into moles and moles into grams. Now it's grams to atoms. So the problem is, how many atoms are in a 3.5 grams sample of sodium, abbreviated as Na? So we have the given 3.5 grams of sodium and the molar mass of sodium, which is 22.98 grams per mole. Okay, we also know that 1 mole of any atom, for this situation, sodium, 1 mole of sodium is equal to 6.022141179 times 10 raised to the 23rd power number of sodium atoms. So, if you want to solve it on your own, please pause as usual. If you do not, then proceed to the next, frame. Okay, so we're back with the solution. So first we have the given 3.5 grams of sodium times 1 mole of sodium over 22.98 grams of sodium. Conversion factor is the inverse molar mass of sodium. So the grams of sodium cancels each other, and then we're left with 0.152 moles of sodium if we divide 3.5 by 22.98. Okay, now from that 0.152 moles of sodium, we multiply it by the Avogadro's constant divided by 1 mole, or the ratio of the number of atoms in a mole. Okay, so if we do that, we can the mole of sodium cancels each other out, and we're left with the unit atoms of sodium. Now we multiply 0.152 and the Avogadro's constant, which is 6.02214179 times 10 raised to the 23rd power, will be left with 9.15 times 10 raised to the 22nd power amount of sodium atoms. Okay, so the steps of converting grams to atoms. So first we convert the grams into moles, and then we convert the moles into atoms. Okay, thank you for watching this video. Please like the video, share it to your friends. If you feel like there's something missing in the video, please feel free to message this page on Facebook so that we can add it in the next videos in the future. And another thing, if you're watching this on YouTube, please don't hesitate to like and subscribe so that we can improve our videos in the future. Thank you very much.